This is the second part of Precalculus Lesson 12. We're looking here at vertical asymptotes of rational functions. This is from section 3.1 in the college algebra textbook. We start with the definition of a vertical asymptote, which is defined to be the line x equals c of the graph of a function y equals f of x if, as x approaches c from the left or as x approaches c from the right, either f of x approaches infinity or f of x approaches negative infinity. As a specific example, we have the graph of f of x equals 1 over x that has a vertical asymptote of x equals 0. You can see represented by a dashed line here. For this particular function, f of x, we can look at the definition, and our c here is 0. So we can see that as x approaches 0 from the left side, f of x is approaching negative infinity, or our y values are becoming larger negative numbers. As x approaches 0 from the right, from the positive side of x equals 0, f of x, or our y value, f of x approaches infinity, or our y values become larger and larger positive numbers. Looking at some specific values for x on the negative side of 0, if we start with x equals negative 1/10 and we get closer to 0 coming in from the left side, we go to negative 1 over 100 to negative 1 over 1000. We can plug these values into f of x, and we can see that y is going to go from negative 10 to negative 100 to negative 1000, indeed approaching negative infinity. For the positive side of x equals 0, if we get closer to 0, starting with 1/10, then going to 100th to 1000th, we have y values of 10, then 100, then 1000. We could keep going. We are indeed approaching positive infinity for our y values here. To identify the vertical asymptote of the rational function f of x equals 1 over x minus 4, we look at a graph, which we could easily get by just moving the graph of f of x equals 1 over x to the right, shifting the graph to the right by 4 units. So we'd have the graph of f of x equals 1 over x minus 4. We could also think of shifting the vertical asymptote of x equals 0 to the right by 4 units to give us a vertical asymptote here of x equals 4. Okay, so if we do that, we're good. But what if we don't want to start with a graph? Because actually, in most cases, we're going to begin with finding the vertical asymptote before we graph the function. So from this function, f of x equals 1 over x minus 4, if I want to identify the vertical asymptote, as long as the function is in simplified form, I can set each factor in the denominator equal to 0, and that will give me the line that is indeed my vertical asymptote. In this case, x equals 4. For the function g of x equals x minus 5 over x squared plus x minus 6, I'm going to factor the denominator into x plus 3 times x minus 2. Verify that the function is in simplified form, which it is here. Then I will set each of these two factors in the denominator, x plus 3 and x minus 2, equal to 0, and end up with vertical asymptotes of x equals negative 3 and x equals 2. The second try on your own for this lesson is to identify the vertical asymptote or asymptotes of the rational function r of x equals x minus 3 over 2x squared plus 5x minus 3.